What I have here is another set of software. This one is from Automation Direct, called DirectLogix. The version I'm using is DirectLogix 5. Now, this is one of the softwares that for the smaller processors, you could download and use this for free. But once you get over 100 words, then you got to pay for it. So a lot of the brick processors can be used with free softwares. Now, for example, we look on this software, and off to the left, I have what's called a cross-reference view. This identifies the terminals being used and how they're identified. X2 is my run button. Terminal X10 is my stop push button. We have terminals Y0, Y1, 2, and 3. These are all my output terminals being used. I'm also using a binary called a C0. Okay, we have counters, CT0, and counter accumulators. So this is the real-time count of a counter. Now, to the right here of this element viewer, this tells me where it is in the program. Rung number 1, address number 1. This is a normally open contact. That's my run button. Position 0, position 1, rung number 1. My stop button is attached to terminal X10 on the PLC. The address in the program is in rung number 1, position 0. It is a normally open contact. So there's my run, there's my stop. Now we go into the outputs. Y0, line number 2, line number 3, line number 4, line number 5, and again the numbering positions are continuous. These are all outputs. And all these are right here are these points. Y0, Y1, Y2, Y3. Now we get down to what's called the binary. This is a C0. That is a binary. It's a virtual relay. So a virtual relay in the processor you can use for whatever reason your little heart desires. Now this binary relay is being used as an output, but when this output activates, it closes the contact up here on line number 1. So we have an address of C0 on rung number 1 and rung number 6. I have a normally open contact, I have an output. Okay, we also use a counter, CT0. So counter number 0, this counter counts to the number 5. Now this counter right there, once it reaches the number 5, that CT0 is down here on this bit on line 6. This is referred to as a done bit. When that counter reaches 5, this contact will close, resetting the counter. Now we also have the counter's accumulator being used on lines 2, 3, 4, and 5. These are all normally open contacts, respective positions on the program. So here we have on line number 2, we have counter 0 accumulator, greater than or equal to 1. Counter 0 accumulator, greater than or equal to 2. Counter 0 accumulator, greater than or equal to 3. Counter 0 accumulator, greater than or equal to 4. Well, when this counter reaches the number 1, the output turns on. When the counter reaches the number 2, the output turns on. When it reaches the number 3, the output turns on. When it reaches the number 4, the output turns on. Once it reaches the number 5, it resets the counter back to 0. Well, we look on the toolbars up here on the top. On the very top, you have your standard Windows toolbar. Then we have the different types of commands that can be used with this CPU and this software. But over here on the right, this is where my commands are to write the program. Here we have edit. We got to be in edit mode and the commands become active. I take it out of edit mode, the commands are not active. So this software is pretty much, it's keyboard actuated. It's not drag and drop like some of the other softwares. Everything is pretty much done on a keyboard. The mouse is used somewhat, but not too often for other than, well, picking out the toolbars. Now what I'm going to do is I'm going to go ahead and connect this PLC, connect this program to the PLC. I click on the connect button. I have to select my communication link that I created, and it's actually going online with the PLC, but it doesn't do anything. Now this is where we have these other types of files. Mode file lets you run or program. Info file gives me the information on the program in the processor, and if there's any errors, it'll spell out what the error is. So if the processor faults, it'll tell me why it faulted. It gives me the name of the program, the user, and the amount of memory that's being used. That's mode, that's info. We have data. This is going to be active data right there that we're really not going to get into in this video. But now here's one that's real good. It's called status. This now identifies the program on what is live and what is not live. In earlier videos we talked about binary numbering, zeros and ones. Some of the softwares have data tables that identify in a tabular form the condition of each individual terminal. Now, most softwares do not have those data tables, but binary still applies. And how we identify when a terminal is 0 or when a terminal is 1 is by the highlight. This contact X10 is currently highlighted. It is now activated, or it is a number 1. It's a binary 1. This terminal run X2 is deactivated. It is a binary 0. So if that terminal is highlighted, it becomes a 0. If it is not highlighted, if it is highlighted, it's a 1. If it is not highlighted, it's a 0. So we can look on the program and identify troubleshooting the program by the binaries or by the highlights. Now if I push the button right here for it's connected to X2, while the indicator light turns on on Y0, the button highlights as a 1, I let go of it and it goes back to a 0. And yet the counter's accumulator went from the number 0 to the number 1. I push that same button again and output number 1 turns on. Okay, it highlights the condition contact, the comparison. We can see 1s and 0s. The highlighted areas are 1s. The areas that are not highlighted are 0s. I let go of the button, it goes back to a 0. Now if I push the button one more time, light number 3 turns on. Push the button again, light number 4 turns on. When I push the button again the 5th time, that brings the counter up to the number 5, and that's going to reset that counter back to 0. Well, you didn't see anything on the screen go to 1 and then 0 because it happens in one scan. One scan is usually about 1/100th of a second. So these scans happen very, very quickly. So now we have different methods to actually work with these programmings. Well, with this stuff like the Direct Logix, if I push the status file button, well, that turns off and I only see the program itself. But when I activate a status, now it shows me the conditions of the programs. So by using things like the element viewer, using things like the element viewer here, this shows me the terminals that are actually being in use. I have terminals X2, X10, terminals Y0, 1, 2, and 3. But notice all the numbers. This is all binary numbering. Well, not binary, this is octal numbering. 0 through 7, 10 through 17, 20 to 27, 30 to 37. Well, different PLCs are going to be based on different numbering systems. So if I'm using some types of math, I could actually come over right here to this little tab that says 10, and I change this number, and now everything I do is in base 10. Screw terminals 0 through 11, 12 through 23, 24 through 35. I can go base 16, hexadecimal. So this not only changes the view of how you look on things numerically, it can change the method you use of mathematics inside of the program. The default for Direct Logic is base 8. Simple to work with, very effective. The basic program you see right here is about as simple as it gets. This is relay ladder logic. And we are going to get deeper into the relay ladder logic. I'm going to go ahead and close this program down and start a new program, a new project. This is fairly easy. All I do is click on File or the New folder, and I say New Project. Let's do it offline. I have to identify the type of system I'm using in the CPU. I'm using a Direct Logix 130. This is a little brick processor, very powerful for a brick. When I bring this thing up, it's a blank screen. The ladder rolls are already here on the right hand side, and I can actually have as many as I need. But now if I want to start doing a program, what I'm going to have to do is I'm going to first thing go to edit mode. Well, this is more keyboard oriented than it is anything else, and it's not as user friendly as some of the other softwares. But now I'm going to actually do the programming of this. Now that I'm in edit mode, I might want to go ahead and put an open contact right here where this black box is. I put an open contact there by clicking on the contact, and it comes up with an alternate contacts menu. The number in the middle is a binary, C0. We don't want to use that. So we got a choice. Check mark is accept, X is delete, and then you got a magnifying glass, which is a search. We click on the magnifying glass and it opens up my element browser. And these are basically all the types of inputs that I could use based on this processor. I'm going to start with this first input, which is X0. But on my PLC, X0 is a different type of a switch, so I want to change this to switch number X1. And I'm going to identify this in description as a stop. This is my stop push button. Now, I can give this a nickname. I can add a wiring number onto that. But until you get good with the programming, I would recommend to avoid this type of information. It can get real confusing real fast on that program until you know exactly what you're doing. Now, once we type in the description, I select it, I accept the change, and now I hit the check mark. There's my stop button. I want another open button. So a black box moves over one. I click my open contact. The alternate contacts menu opens up, and again I click on search. This time I want to use terminal number X2. This is going to be a start button. So we type in the word start. We select it, save it, check mark. Well, for the output right here, these outputs are already on the line, called a normal output or NOP. Okay, all I do at this point is highlight the box and double click on the box. Again, it opens up my menu. I click on the magnifying glass to search, and now I click on the Y's. Y is output. I'm going to use the first output, which is on my board as a green light. Okay, the description here, we can call it load number 1. I'm going to select it, I'm going to save it, I hit the check mark. Well, that looks kind of easy. But now I got to put a branch around the start button. They don't have a command for this. So this is where software like this gets tricky. I highlight the box next to the start button. I hold the control button down on the keyboard. I arrow down. I move this box to the other side to the stop button. This line will be drawn on the left side of that black box. Control button, arrow down. Now that I've got that two branches on there where that black box is, I just click on Open Contact. And I'm going to address this contact to the load, which is Y0. Once it's already identified, all we got to do is type it, Y0. Hit the enter button, we're good. So here we have one line of programming. Well, simple programming, this CPU will scan this program forever and never stop. This is why every PLC at the end of the program will have the word end. So we simply highlight the box black and we type in the word END. Enter, enter. Well, right there we just completed a simple program for a 3-wire control or a holding circuit. Off to the left right there, I don't have any letters to identify this line has been edited, but this yellow bar right here identifies this rung has been edited. Actually, these two rungs have been edited. Now, if I want to check my work, all I have to do is click on the word accept. And that bar turns color, moves to the left. These rungs would actually work correctly inside of the PLC. It also comes up with my cross-reference view, telling me which terminals have been used on the PLC, what they're being used for, and what rung they're on, and what the address is. On a large program, this is very useful information. Very useful. Now, if I want to make this system work, I'm going to have to download it to the PLC. So I simply click on the Connect button. It opens up a link button right here. Let's go ahead, just for the giggles of it, let's go ahead and see how this works. We're going to go ahead and edit this. Well, number one, I had to go over to the PLC and identify what type of PLC I'm using. I had to pick out which port I'm using on the computer. This is typically going to be a conversion port, or if your computer still has a serial port, whatever that serial port number is. But right over here where it says port, we have over here the word auto. Every communications program will have the word auto. All we got to do is click on it. And it automatically checks every possible configuration and gives us the best. We accept it. Okay, we select this, and now we're going to communicate. We're actually communicating with the PLC. Well, the program on the computer is different than that in the PLC. So I could copy the program from the PLC to the computer. I can use the computer program and copy it to the PLC. Which, that's what I'm going to do. So I click on Use Disk. So this copied the program and overwrote or erased the memory in the PLC and replaced it. Well, it's not doing anything here, so we click on Status. And once I click on the status file, now the buttons are going to hold. So we got button number 1. That's now my stop button. I push button number 2 or terminal number 2, start button. The output turned on, the output latched on. If we look on this in binary, it says 1 or 1 equals 1. 1 and 0 or 1 equals 1. We look at it in logic. There has to be a complete path for logic to actually flow to make this circuit work. What I'm going to do here is I'm going to go ahead and run through the circuit, and if I actually have that stop button closed in the field, it activates the contact right there in the program. which means now all I have to do is push the button attached to terminal X2. When I do that, the output turns on, the output latches on, I let go of the button, and the circuit is latched on. Now when I go ahead and push the stop button again, it breaks the circuit. So here we have a start-stop station in a program, the same exact way we do with motor controls. Start-stop stations. Start, stop. Often referred to as a three-wire control. Now the program, because you can identify which contacts on the lines are zeros and ones, makes it very easy to use a software for troubleshooting purposes on a piece of equipment. And we will get into that. So, DirectLogic's simple software, not as friendly as some of the other ones, but yet easy to use, and for the smaller processors, it's free.